Hello guys, welcome to my video. Most programmers know how to write a simple loop. Very few understand what happens when the operating system decides to ruthlessly kill that loop. By default, if the Linux kernel sends an alarm or a termination signal to your program, it crashes instantly. If you're running a low latency trading algorithm or a multi-threaded server, sudden death is catastrophic. You leave memory locked and data corrupted. Today, I'll show you how to hijack a POSIX kernel interrupt in C++ so your system can catch the signal, print a heartbeat, and shut down safely. Let's look at the code. Down in our main function, we have an infinite loop, as you can see here. Right above it, we set an alarm 5 to fire in exactly 5 seconds. This alarm just sends a signal to the operating system, which tells it to shut down the program, but we're manually sending it in this case. So normally this alarm would kill the process, obviously, but on the next line, we use a signal system call. This tells the operating system, do not kill the program right now, route the system to our custom function instead, which we have defined here. This is our custom handler. When the kernel fires the alarm, it pauses the main loop and jumps here. So basically, it goes through here. As soon as this alarm comes from the system, it pauses the execution of the code and jumps straight to the signal handler, which does its thing and exits. As a note, printf is not the ideal situation in our production system because it isn't strictly async safe, signal safe due to like internal locks, but it's perfectly fine for this demo. So let's run it. Because our main loop is taking every second, it's gonna wait for 5 seconds until the kernel intervenes and it runs our function, our custom handler that we built. So I have already compiled the system. I'll compile it again in front of you. So it compiled the system. I will run it. So it's running the loop for 5 seconds. Should you print 5 times? So it does that, and then it straight sends to the signal handler to handle it. So this is the exact foundation of a robust, fault-tolerant infrastructure in Linux. Thank you for watching.